Is Proxima B the cosmic twin of Earth? Since its discovery in 2016, the exoplanet Proxima B, the closest planet to Earth, has been suspected of hiding an exciting mystery. It could be surprisingly similar to our home planet and might even harbor life. Despite its proximity, Proxima B has long concealed its true nature, but today, the James Webb Telescope is tackling our neighbor to uncover its true background. So, what have astronomers discovered? What is the story behind the mysterious signal from the Proxima Centauri system, which may have an artificial origin? And is it true that Webb has spotted an extraterrestrial metropolis, brilliantly illuminated? Let's start with a little test. How many planets are there in reality? 8 or 9? Because we sometimes count Pluto as well. However, we must not forget one thing. There are countless planetary worlds beyond our solar system. We've discovered no fewer than 6,911 planets in 4,941 systems that orbit stars other than the Sun. However, the celestial bodies detected so far are just the tip of the cosmic iceberg. Experts estimate that there are up to 50 billion more planets, and this is just within the Milky Way galaxy. And if we recall that our home galaxy is only one of billions of others in the universe, a fundamental question arises. Given the overwhelming abundance of the universe, is it even conceivable that Earth is the only celestial body to have given birth to life? Many scientists answer what is perhaps the oldest question in humanity's history with a resounding no, and they believe it is only a matter of time before we meet our extraterrestrial neighbors for the first time. And as the saying goes, why go far when the alien is so close? It might be that the next extraterrestrial civilization lies practically at our doorstep. After all, no other known exoplanet is as close to us as Proxima B. The distance that separates us from this alien world is only 4.2 light-years, which, let's be honest, is still a huge distance. 37.84 trillion kilometers. With our current technology, it would take 6,300 years to cross this enormous distance. Fortunately, humanity is in the comfortable position of being able to explore the mysteries of space without having to leave its own planet. As mentioned earlier, we have known about the existence of our closest neighbor, Proxima B, since 2016. We also know that Proxima B orbits its eponymous star, Proxima Centauri, in the Centaurus constellation. It is accompanied by at least 2 other planets. But how do we find a celestial body that is over 37,000 billion kilometers away? Are today's James Webb telescopes really so powerful that they can directly track these extraterrestrial worlds and capture them on film? Well, not quite. The truth is that indirect detection methods have become the most reliable means of success. This is particularly the case with the transit method, in which a planet reveals its presence by altering the brightness of its star as it passes in front. For Proxima B, it was the radial velocity method that revealed its existence. In simple terms, this detection principle works as follows. A star exerts gravitational force on a planet, causing the planet to orbit around it. In return, the planet also exerts a slight gravitational pull on the star, causing it to wobble or sway ever so slightly. Although this stellar wobble may only be a few centimeters, it is enough to signal to astronomers that our star maps need an update. Is Proxima B Earth 2.0? To be included in the list of potentially habitable worlds, a planet must first meet a basic requirement. It must be located in the habitable zone of its parent system. In other words, it must orbit its star at a distance that allows liquid water to exist on its surface. However, the mere presence of liquid water is not enough. Other factors, such as the planet's atmosphere and the radiation emitted by its star, could thwart the development of life. So, what about Proxima B? With a mass of 1.17 times that of Earth, the celestial body is considered a terrestrial exoplanet. But before we get too excited, the term Earth-like refers only to rocky planets with a solid surface, without implying habitability. While Earth takes 365 days to orbit the Sun, Proxima B only takes about 11 days. This is due to its short distance from its parent star. While the average distance between the Sun and Earth is about 150 million kilometers, Proxima B orbits its star at a distance of only 7 million kilometers. Under these conditions, one might reasonably assume that the planet would be scorching hot on its surface, and that's true, but only half of the time. In fact, Proxima Centauri is a red dwarf star that is only about 12% the mass of the Sun. However, data gathered so far suggests that Proxima B is tidally locked, meaning it always shows the same side to its star. Consequently, the exoplanet is divided into a cold night side and a much hotter day side. This extreme contrast could rule out the possibility of habitability. But perhaps there is a narrow band between these two extremes where conditions could be conducive to life. Researchers' simulations have shown that the habitable zone could benefit from water in liquid form from the ice sheets on the night side, which would melt near the twilight zone, feeding lakes and rivers. What about the temperature? Experts have calculated an equilibrium temperature of minus 39 degrees Celsius. Let's briefly explain equilibrium temperature. It is the temperature that a system settles into after a long enough time. However, this does not mean that the equilibrium temperature corresponds to the surface temperature, as Proxima B may have an atmosphere that could be much warmer due to the greenhouse effect, a situation that Earth also teaches us a thing or two about. Without an atmosphere, Earth's equilibrium temperature would be minus 18 degrees Celsius. Is there life on Proxima B? Well, the answer to this question, or more precisely, to the question of whether liquid water exists, depends on a number of factors that have not yet been conclusively studied. Assuming an appropriate orbit and a positive atmosphere, a 2017 study concluded that liquid water could indeed exist on Proxima B. Despite this, the planet's actual habitability is still heavily debated, mainly because the intense activity of its parent star might hinder the development of life. A few years ago, researchers from the University of Colorado observed something unusual that eclipsed previous data. They found that Proxima Centauri's flare activity was 100 times more powerful than any solar flare ever observed. In just a few seconds, the star emitted a burst of radiation far more intense than anything previously recorded. In fact, the eruptions that occur there are not only much more intense than in our own system, but also much more frequent. In this context, one could therefore assume that the extreme radiation will ultimately destroy the atmosphere of Proxima B, thus annihilating any chance of development of life. Yet, if the exoplanet had a social media account, we would still read it's complicated in its status. This is because there is a scenario in which Proxima B does not lose its atmosphere into space. For that, it would need a liquid core that forms a stable magnetic field, thus protecting the planet from the dangerous radiation of its parent star. In this way, oxygen and water molecules could be preserved on the planet, and it is also conceivable that the star draws energy from its original reserve. In detail, one theory claims that the exoplanet actually formed at a much greater distance from its central star and was only later captured by its gravitational pull. It is also conceivable that there was once 10 times more water on Proxima B than on Earth. Even if the extreme radiation had already stolen 90% of the water, enough would remain today to cover large parts of the planet's surface with a massive ocean. But as you can already imagine, the temperature of the water would only be moderate in the narrow twilight zone on the night side. On the day side, the water would resemble a boiling pot. Mysterious signals and artificial lights from cities. If there really are highly developed extraterrestrial civilizations, they must have left behind some trace. Since 2015, members of the Breakthrough Listen project have been dedicated to the exciting task of tracking down these revealing signals in space. And presto! In 2020, researchers did indeed capture a potential radio signal coming from the Proxima Centauri system, which was immediately suspected to be the signature of a hidden extraterrestrial race. Then came the headlines claiming that the James Webb Telescope had detected a bright carpet of artificial city lights on Proxima B. Could it be clearer? Of course not, because it is clearly a fake story. In detail, we are dealing with a severe distortion of another exciting discovery. In reality, Webb had detected an intriguing glow of methane in the brown dwarf domain W1935, but this has nothing to do with extraterrestrial civilizations. As for the radio signal, in this case, the analysis revealed a disappointing outcome for all extraterrestrial enthusiasts. The signal, called BLC-1, was ultimately of terrestrial origin. It was created by the distortion of Earth-based radio signals. As a result, the mysterious, wow, signal of 1977 remains the most promising candidate when it comes to the question of extraterrestrial messages. Experts are now placing their hopes on the future observations of the James Webb Telescope. Could the Webb telescope directly observe Proxima B and film the exoplanet? Unfortunately, there is a big problem. The celestial body orbits so close to its parent star that it can barely be distinguished. However, researchers are currently looking for some lucky circumstances and tricks that will allow them to closely observe the alien world using spectroscopy. And now, we will reveal a trick that will allow you to regularly watch our videos. Just press the like button and subscribe to stay up to date.